Welcome to the Open Ventilator Systems Initiative. My name is Joel Ratner-Shafi and I have been working with this consortium for the last 2 weeks. We have a working prototype that meets the government call out for a rapidly manufactured ventilation system.
What makes our project different is our inclusive innovation approach. At least half the world's population doesn't have access to ventilators at all. We're changing this by designing machines that are 1/10 of the cost, but equally as good as ventilators that are used here in Europe.
We had to make everything in the lab ourselves. Safety critical systems like safety valves, pressure regulators, solenoid valves, throttle controllers, flow meters. That's all been made, tested, and shows compliance and compatibility with ventilator requirements.
And this is interesting for a number of reasons. Firstly, we're looking at how we can actually minimize the effort and the time to meet regulatory standards. So by using widely available parts. And the other important component is actually thinking about, can we use parts that can be sourced around the world? So this allows it not just to be used perhaps in the UK, but also anywhere in the world where you might have even fewer ventilators, and it is actually increasingly harder to access the technologies and manufacturing capabilities. So we're looking not just at the design, but how this maps to both the supply chain, the regulatory issues, and also how this can be manufactured and actually distributed to the people that need it most.
My name's James Taylor, and I'm an engineer working at the Whittle Laboratory. What I normally do is research new fluid mechanics for jet engines and gas turbines, trying to improve efficiency. But what I've been helping this team on the ventilator project is deal with some of the fluid dynamics problems in it. So the design that we've come up with is inherently safe because of its simple architecture and its mechanical sort of control. And what I've been doing in that is designing some of the components so that we can regulate the pressure to very precise and stable values so that then it can be delivered to the patient very reliably. So because we can understand the fluid mechanics inside the system itself, and we can design them to be stable and safe, that means we can make them simpler and cheaper and easier to make and more readily available for everyone.
We're also designing to address such challenges that might be faced in developing countries, such as not having piped oxygen or perhaps having intermittent or unreliable electricity supplies. And we've worked with medics and engineers in Ethiopia, Kenya, and Uganda to make sure the design is exactly what's needed in those countries. Ultimately, it will be possible to build and maintain the ventilators in country, which will contribute to job creation there and enhance the resilience of health systems in the long run.
In Africa, we have a phrase called Ubuntu, which means togetherness and being one. To me, it's the Ubuntu of ventilation.